Okay, here we have this cube which has sides of length L, which we're going to compress down, and we're going to compress it down so that each side has half its original length. So it's going to get compressed down over here to 1/2 L. 1/2 L here, or just call it L over 2, L over 2, L over 2. And we want to know what's the density of this new one here, what's the density of this one compared to the density of this one. This one has a density of rho, right? So, we have density is mass per volume, right? So density here is the mass per volume. So that's equal to the mass divided by L cubed, right? That's the density of this one. Then the density of the one over here that we've compressed, I'll call this rho 2, density 2. This one is going to be the same mass divided by a volume, but the volume here is still a cube, but now it's 1/2 L cubed, right? So this is 1/2, mass over 1/2 cubed, which is 1/8, times L cubed, which is just, then L cubed, right? Okay, and then we divide by 1/8. We get this is equal to, bring the 8 on top. This is 8m over L cubed, right? But m over L cubed, this is that, which is rho, right? And so the density of this new one, rho 2, is equal to 8 times the density of the old one, which makes sense, right? If we take and compress the block down, the cube down, so that the volume is 1/8, then the density will be 8 times as much, assuming we keep the same mass, right? This is because we have an inverse relationship with the volume, right? Density is inversely related with the volume, directly directly proportional to the mass, right? So by decreasing the volume by 1/8, I increase the density by 8. Okay, so it would be 8 times as much. Then part B asks us, if you keep the mass and shape the same, so still a cube, what would the length of each side have to be so that the density of the cube was 3 times its original value? So we'll want this kind of a new density, right? So we want, call this density 3. We want that to be 3 times the original density, okay? So I'm going to take and I'm going to compress it down, and I'll have new side lengths of x, whatever that is. I don't know what it is. That's what we're looking for. I'll just give it a variable. In this case, I'll give it x. Okay, so the density of this one, the density 3, that's going to be mass over x cubed, right? So we need mass over x cubed. This new side length cube needs to be 3 times mass over L cubed, right? That was our original density there. And, we'll divide through by mass, and mass will cancel out. We can just solve this thing for L, right? And we have, we're going to solve it for x, right? We want the new side length. So we're going to have x cubed will be equal to, this is going to have to be it's going to be L cubed over 3, right? And do all the algebra there, a couple steps together, multiplying both sides by L cubed, dividing both sides by 3, dividing both sides by m. We get x cubed is equal to L cubed over 3. And so when we take the cube root of this, take the cube root here, then, this is going to be, the cube root of L cubed divided by the cube root of 3, right? So x, this new length, needs to be 1 over the cube root of 3 L times as much, right? So I need to make it not 1/3 as much, but 1 over the cube root of 3 times as much, whatever number that is. And you can think about this here, like, okay, when I cube it, right, I'm going to end up with 1/3 the length cubed. I'll end up with 1/3 the volume, right? So when you take this whole thing here, I'm going to end up with 1/3 of the volume that I had originally. This new one will have, 1/3 of the original volume, therefore 3 times the density, right? Which is what we were looking for, 3 times the original density. So the new length, the new x, needs to be this in black.